Hello, my name is Janelle Lewis, and this is my regression project on ice cream consumption for MBA 517. Here are some ice cream facts that I retrieved from the International Foods Association. The average American consumes almost 22 pounds of ice cream per year. U.S. ice cream companies made more than 872 million gallons of ice cream in 2014. Summer is the season with the highest ice cream consumption and related products, and June is the highest production month of the year for ice cream. These facts, as well as economic principles with regards to demand and price and also demand and income, help me to formulate my hypothesis for ice cream consumption. My hypothesis is I wonder if the price of ice cream, temperature, and income of an individual will affect ice cream consumption. The null hypothesis is that price of ice cream, temperature, and income do not affect ice cream consumption. And then my alternative hypothesis is that price of ice cream, temperature, and income do affect ice cream consumption. For this study, I am looking to prove the alternative hypothesis. Other questions that I am looking to answer and consider are what causes the greatest or the greater increase in ice cream consumption? Is it temperature, price, or income? Also, at a given income, price, and temperature, can consumption be predicted? By how much does consumption increase with each 10-degree temperature increase? My independent variables for the study are income, price, and temperature. The income is for families, the average income for a family. The price is the price of a pint of ice cream. And the temperature is just the temperature of the day recorded in Fahrenheit, degrees Fahrenheit. The dependent variable is ice cream consumption. And price is my binary dummy variable, with 1 representing a price that is greater than 0.275 and 0 representing a price that is less than 0.275. Here is my data that I retrieved from the demand relations with autocorrelated disturbances. And this was one of the sample data that was provided in MBA 517. I used this data to construct 2 scatter plots. Here I have my first scatter plot, income as it relates to consumption. And you can see that my linear trend line here is relatively flat, which shows that there is little to no correlation between income and consumption. However, for temperature as it relates to consumption, I see that there is a linear relationship, a positive linear relationship between temperature and consumption. I was able to look at my summary output for this data to get a little bit more information about the data. So the first thing that I looked at was my R squared, which is 73%. And this basically tells me that 73% of the variation in Y can be attributed to my independent variables. So this means that 73% of the variation in consumption can be attributed to income, price, and temperature. I wanted to also check to see if my model was statistically significant. So I looked at my F value, and based on the F test, this number is less than 1. So this means that the entire model is statistically significant. Overall, the model is statistically significant. I also was able to determine if each independent variable was statistically significant by looking at the p-values. So for income, my p-value was 0.0066, which is less than 0.05. So income is statistically significant. However, price, my p-value was 0.096, which is greater than 0.05. So this means that price is statistically insignificant. And this basically means that there's unlikely a relationship between price and consumption. There's unlikely to be a relationship between those two. For temperature, my p-value, we see it here. This is less than 0.05, so temperature is statistically significant. I could also look at my coefficients, and these tell me a couple of things as well. For example, I know that if I have a 1 unit increase in income, there's going to be a 0.0034 increase in consumption. For price, if I have a 1 unit increase in price, I know that there's going to be a 0.023 decrease, because price here, the coefficient is negative, so there's going to be a decrease in consumption. For temperature, for every 1 unit increase I have in temperature, there's going to be a 0.0036 increase in consumption. So with this, I can answer one of my questions. I know that if there's going to be a 10-degree increase in temperature, then my consumption is going to increase by 0.036. And this is based on the coefficients here. I can also use these coefficients and also the intercept to make my regression equation. And here C represents consumption, M is my income, P is my price, and T is my temperature. And I can use this equation to calculate the consumption if I have a given income, a given price, and a given temperature. For an example, if the price of ice cream is $3 and the temperature is 70 degrees Fahrenheit and an individual income is $100 per week, their ice cream consumption would be 0.428 pints per person. And this is calculated by simply plugging in the given numbers into the regression equation and calculating the consumption for each person in this example. So why is all this information helpful? It is helpful because it helps ice cream suppliers to predict when they need to produce more ice cream. So for an example, temperature and consumption had the strongest positive linear relationship. So I know that, or suppliers will know that they need to base their production on temperature. So during the summer months, as was seen in some of the data that I retrieved from the International Foods Association, most suppliers will produce more ice cream. This is because, as we see in this data, the higher the temperature, the more people are likely to consume ice cream. Also, it may be helpful for consumers because they can predict when they will consume the most ice cream. So, for example, if I'm a consumer that is, let's say, health conscious, if I know that I'm going to like to have more ice cream in the summer months, maybe I'll also plan to exercise more during the summer months to counterbalance my ice cream consumption. So those are just some thoughts on how this information could be helpful to suppliers and consumers. So from this data and data analysis, I was able to conclude a few things. For an example, temperature has the greatest impact on consumption. I was able to see that in the scatter plot that I had for temperature versus consumption. And also I was able to look at that with the number of the coefficient for consumption. Price was not statistically significant. And I think that this is most likely because there was not much of a variation in the price for the data that I received. I think that price will be more statistically significant if there was a greater increase in price. For an example, as a consumer, I don't think that I would be affected by a 1 or 2 cent change in the price of ice cream. However, if ice cream goes up by a $1 or $2 change, then I do think that it would be statistically significant and it would definitely affect consumption. I also noticed from this data that income had little to no impact on consumption, and I was able to see this as well from the scatter plot. The line was pretty flat, so it did not have as much effect as I thought it would, but overall, temperature had the greatest impact. Thank you so much for listening to my presentation.